So let's look here. A sprinter can accelerate with constant acceleration for 2.3 seconds before reaching top speed. He can reach the 100-meter dash in, or, whatever the values are. I don't know, like 2 seconds, and maybe a 100-meter dash in like 10 seconds. But this to me is basically screaming, use of two equations, right? VF squared, I'm just going to write them both out and see which one seems more appropriate. 2a delta x, and delta x is equal to v naught t plus 1/2 a t squared. So v naught is 0. V naught is 0. And we do know the time. We do know the distance, and we do know the acceleration. We're just trying to find the final speed, right?
Wait, we know the acceleration, or is it
Yeah.
when it means it's only constant, it's only 9.8?
Oh, you're right. We don't know the acceleration, do we? I'm sorry, we don't. We know how long it is. Sorry, I read that problem wrong. My bad. But yeah, we know delta x. We know. Oh, I'm sorry. I read this problem wrong. It's saying that he accelerates for some period of time before reaching top speed, at which point it's presumed that he runs at a constant speed. So to draw this, it's sort of like saying, he's accelerating over this period, and then acceleration is equal to 0 afterwards.
Yeah, okay, yeah.
Gotcha. My bad. Thank you for correcting me. But okay. So what's going to be important? Okay, let's just try to draw this out again. Yeah. We got to the end of the problems that I quickly glanced over, so I'm sort of working these on the fly. But if t naught is equal to 0 again, and then t2 is essentially equal to 10 seconds or whatever it is. I think Usain Bolt actually runs a little bit faster, but we'll ignore that. It's basically saying that this distance right here, this distance covered right here is going to be t2 minus t1 times whatever velocity at 1 is. Yeah? And this distance right here is just whatever is left over. What's up?
Oh, can you say it again,
Yeah.
please?
So if he accelerates to speed t1 at this point, and then everything that's left is just, this distance right here is basically his velocity, the top speed, times the time of the interval, which is just t2 minus t1. Yeah? So then this distance is just 100 minus t2 minus t1 times v1. We also know that v1 is equal to t1 times a. That's just describing the period over which he's accelerating. And yeah, what else do we need to know here? What is this? They're basically asking us to find v1 at the end of the day. It's t1a. Okay. I'm going to write down some equations. So v1 squared is equal to v naught squared, which is just 0, plus 2a delta x, where delta x is equal to this value over here, the 100 minus this thing. This is tough. Or maybe I'm just being dumb. Because we don't know what v1 is. We don't know what a is. And we also don't know what t1 is.
And when they just say part A and that's it, I usually think it's gonna be a long one.
Yeah.
It's gonna be like a lot of equations.
But this problem doesn't have that many details, so perhaps we're just doing something a little bit, maybe I'm just being a little bit blind right here. I feel dumb. I feel like I must be making a really, really simple error somewhere, or overlooking a perfectly good equation for some reason. But what am I not using here? We're told that they accelerate for some period of time. I'm so stupid. They told us what the value of t1 is. We didn't have to solve for it at all. They told us what T1 is.
The 2.30 or the 10 seconds?
The 2.30, I think. Oh my goodness, I'm sorry. I've been making this so complicated. It's really, at this point, it's just one equation and one unknown. This is known. All these values are known. The only value you need to solve for is V1. Yeah, I'm sorry for making that more complicated. Maybe I'm just too tired today. Do you see that? This is actually not that complicated of a question. I think I just read it really wrong. I had completely forgotten that one of the values was given. Do you see what I mean?
So I'll just like be able to just plug it into a kinematic equation. It should give me the answer.
Yeah. No, this one was probably my bad. I forgot that T1 was already known, and plugging it into your kinematic equation of choice, like this one over here, will essentially let you solve.